My name is Selena. I work for Mozilla, and I'm here today to talk about this tool that a couple of my coworkers have been working on. One coworker in particular, Peter, he wrote, it's called Crontab, and we recently spun it out of the larger open source project that I work on called Socorro. But before I get to that, I was really inspired by James Mickens' talk yesterday, and so I thought I'd tell you a little bit more about myself before I talk to you for a very long time about cron. And some of you from the Portland area may know that I keep chickens, and yeah, they're great chickens. You guys love chickens, right? So here's a picture of the most recent coop that my husband designed and made. We call it the Chicken Palace. You're only seeing a small portion of the Chicken Palace here. And you can see right there, well, it's kind of dark, but you can see there's a chicken kind of like perched in there. That's Chip. She was looking through the window last fall. In addition to keeping chickens, I also like to make diagrams. And so this is a diagram of all the locations in my backyard where chickens have died. I gave a talk about my early efforts to keep chickens alive, and that got me sort of a bad reputation in the local chicken keeping community on the mailing list. But if you'd like to know more about that, there's a link there with a video that you'll learn a lot about me. Here's a more recent diagram that I made that describes our N+1 replication. I'm sure that puts a lot of faith into our infrastructure there. That's our reporting systems for Postgres. And I thought I'd share with you a couple of things that I learned because one of my other coworkers, Lana, is here, and I heard he went out drinking with some people last night. And we learned, once again, that people have never seen about crashes. So Socorro is a crash reporting or collection system that we use, and the crash reporter that's built into Firefox sends those crashes to us, and you can actually look at all of the crashes that you've had, which I'm sure there are very, very few. You can look at them at about : crashes. And those are actually links. If you click on them, you go to this site that we maintain, crashstats.mozilla.com. It'll tell you a little more about your crash report. If you click on, I don't know if you can read it right there, but it says more reports, you can see who else has reported similar crashes. And thanks to the comment field, you can read about how other people feel about their crashes. So they sort of start with pleading for fixes. Direct language, in a lot of different languages, actually. Sometimes they resort to threats. And if you'd like to just have like a stream of these comments coming to you all day long, my other coworker, Adrian, made this great site that will help you keep up to date with how people are feeling about their crashes. So mostly I contribute Python and SQL to Socorro itself, and I'm currently working on a large migration away from Hadoop and HBase actually in our infrastructure. This is one of my favorite diagrams. So I'm a major contributor to Postgres, and you can see how Postgres features very prominently in this diagram. This was made by a contributor named Mark who sadly passed away, but he certainly had a gift for making things prominently feature my favorite database. This does need to be a little bit updated for some things, but it does represent kind of the main architectural elements of Socorro today. And I also make some other diagrams. This is one that I like to call how Firefox gets made. This is in honor of our release management team that was here in Portland last week. And what I mean by that is like way up at the top there, that's where the commits are coming in, and way down here at the bottom is where they kind of end up coming out in the FTP server, the binary builds come out. And magenta bars, those are places where things might break and cause our tree to close. So This is the kind of stuff that I really love doing, exposing sort of exactly what it takes to make things work based on what people are actually doing as opposed to how we imagine that they might have worked. Getting back to Crontab, here's what I mean by the final Crontab. This Crontab could be your Crontab. We still run Crontab from Cron, but we're considering making it a standalone system in the relatively near future. I stripped out the full path. It's like shows you exactly where everything's running in our system, but this is pretty much what it's come down to for us in a Crontab that used to be quite a bit more complicated. And Eric Booth's talk inspired me to include this. I don't know, have you ever seen Skeletor is Love? Have you seen that? Yeah, so I wish that my story today was all just happy unicorns pooping donuts and Skeletor riding it, but it's really mostly a story about making a tool that solves a specific set of problems that we had. And I think a couple of the features that came out of that significantly improve Cron in a very generalizable way, which is why it's now its own open source project. So why did we create yet another thing like Cron but different? So I don't know if you've seen the 5-word tech horror stories that were out there that was going around a couple months ago. Well, I came up with some 3-word ones to sort of describe the issues that we were up against that created Crontab. So the first one was that we didn't have any unit tests specifically for the cron jobs that we were running, and really I could have shortened this to 2 words, which was that we had pretty much no tests. So we had these sort of fragile cron jobs that our systems really depended on, and we weren't really sure what appropriate input or output in some cases should have been. I'm sure none of you here, though, have that problem. And maybe this also goes without saying, but we had some very, very special shell scripts. Some needed a little more help with consistent variable naming and setting. Some had that, others didn't. They needed a lot of care and tending, and really, really weren't fun to deal with when we changed our integration testing or our configuration in a substantial way. And it sort of pains me to put this slide up here because I really do love Postgres. But these stored procedures were really difficult and occasionally terrifying to the developers. And they were fragile in ways that weren't easily debugged by Python developers, to be perfectly honest. Like running the same stored procedure twice with the same date would just break in this horrible exception-throwing way, and people didn't really know how to debug it. And this is one of my favorites, email from cron. You can probably all relate to email floods that have happened from cron. And here's a graph. I spent a little time with iMathLib last night. And here's the inbox of my, the cron inbox of my coworker, Rob. As you can see, there's a lot of email in there. And each one of those dots is how much email came in a month. And you can see in 1 month, that was somewhere upwards of 22,000 messages. And that's just actually filtering out the things that had cron in the subject line. There was a lot more in there. And so to be perfectly honest again, here's where we implemented Crontab. So just because we solved some of these problems, it didn't really save us from later spikes in email. But one thing that I will say about it is that we don't really need to read that stuff anymore. It's there, we're collecting it, it's like a little, like Linus's little like safety blanket, but we don't really need these things anymore, and that's, I think, the value of this system. Mostly we use Nagios and Sentry to look at this data now. So before we get into Crontab's features, I put a list together of the things that people told me that they use cron for. So everything looks like a nail when you've got a hammer. So birthday reminders, of course. Status updates for websites. Doxygen output, yes. Email names about bugs that are filed wrong. ETL, of course. Batch processing, backups, machine heartbeat, my favorite from my favorite Australian, sweet fuck all. Auto updates, logging laptop IP. People just use cron for all kinds of stuff. And maybe that comes down to, of course, running jobs on a predictable schedule, right? For us, how we tend to use it are for time-dependent reports maintenance, very simple event detection, leaving more complicated event detection to other systems, and then sometimes status logging. And very specifically, the stuff that we're using for, like I said, these stored procedures for materialized views in Postgres, daily map reduces, although we're starting to eliminate that from our workflows. FTP scraping, always delightful. Bulk email responses to crash submissions, because we like to tell people that we got their crashes and we're grateful that you sent them to us. We pull that out of Elasticsearch. So the thing about these jobs, in addition to the time sensitivity of them, because our Postgres map views their daily rollups of data, and we need them to be run kind of at a certain time. They're often very fragile and complex, and we tend to like to put the very simple jobs with few dependencies into our queue systems, but these other things that are more fragile and a lot more complex, and sometimes things that we only run for a short period of time into Crontab. But at least for now, Crontab is really solving these kinds of problems for us very well. So if you want to take a look at the source, we spun it out of Socorro a couple months ago and are now running it in our stage environment, and it'll go into production probably in the next 1 or 2 weeks. The people who are primarily responsible for this are Peter, who's awesome, and Lars, also awesome, and there are their GitHub handles. And if you want to get it, you can just pip install and play around with it. Of course, you can also pull the source, but pip install is kind of nice. Here's kind of our Crontab jobs. That's just actually a portion of them, it's not all of them. They're all Python classes, which you might have noticed if you're familiar with Python. And they all have a run method in them, and that's the basic structure that everything operates on. They require a couple parameters, like, you know, if it's hourly, you can just say like 1 hour, but if it's daily, you need to actually specify a time. But this is our, the basic unit of configuration for all of these jobs. Then we have some classes. Most of our classes are defined as subclasses of base cron app, which is something that we provide. And like I mentioned, they only have like a few limited requirements. We ask for like app name, app version, app description, and then a run function. And then you can do whatever you need to do in your cron. I'm showing how we make pretty extensive use here of decorators to keep our code really clean, but you don't have to operate this way. Obviously, you can shove a lot more logic into these. We, in general, use a lot of abstraction in our systems. So, you know, behind the scenes, we're doing a lot of Postgres transaction management. But the code's all open source, and all of these modules, eventually we're hoping to kind of spin them out and make them easier for other people to use. But the base classes are already there. And then here's how we manage our materialized views. There's a lot of complicated stuff in here, again, like really a lot of transaction management that we're doing. But what it comes down to for us are things like this. So we wrote this one time, and then that long list of jobs that I showed you earlier, most of them are written like this. And all that's doing is it's running a stored procedure in Postgres and documenting a couple dependencies that need to be run before it is run. So another piece that I unfortunately don't have enough time to talk about today, but configman is the configuration system that we use. It's largely written by Lars. And it's an important piece of the way that we run things. But like I said, I don't really have enough time to explain it to you now. It takes some getting used to this configuration system. Once you get into a place that it works really well. But most of you, I'm guessing, won't need to provide as much abstraction or complexity as we, by default, use. So anyway, if you need it, you have the ability to get really modular, but you don't have to. So what is it that I really actually love about this system now? Well, we don't write shell scripts anymore. That's amazing. It's really nice to have systems that are easily testable. There is unfortunately one shell script that we have left that we're using. We're moving away from scripts like this as we've gotten more control over our infrastructure. Some of the reasons why we do stuff like this is because it was very hard to change configuration in the early days, but now we have more control of that, so we're kind of shifting more to just running Python straight up and not using stuff like this. But other than this, we don't really need to write shell scripts for our cron jobs anymore. The key killer feature for Crontab is that it retries on failure. The base app class understands how to do the retries, and a failure is defined as a cron job that just throws exceptions. And so all that cron mail that we get on things failing, we'll get a notification that something failed if we configure it to tell us that, but then later on, Crontab will retry it all on its own. The other thing that is killer for us is that it waits to run if a dependency fails. So those dependencies that we document, this is really important for us because we have this thing called average daily instance, which tries to calculate, how many instances of Firefox are out there running at any given time. But we only roll that up once a day, and we're actually relying on a completely separate system to deliver that information to us. So if that's late, kind of a bummer, and all these jobs are failing. And so now we only just have the parent job that fails, and then once it succeeds, then all of the rest of the materialized views can run. Another thing that has made everyone's life way better is Nagios alerts. The Nagios alerts are built in. It makes the emails, like I said, from our cron job something that we just don't need to pay attention to anymore. And they come to us in IRC like this. It just throws the name of the job of the app that's affected. We immediately know what's failing. And rather than getting sort of a more generic alert about cron or Crontab itself, it tells us specifically, here's the job that you need to pay attention to that's gone bad. We also have a configurable number of failures before it goes critical. So a lot of times we'll see a couple of warnings for that average daily instance job before it'll actually go critical. We need to go and poke somebody in the other team and see what really went wrong. But a lot of times, they've got a semi-resilient system as well, and they'll retry and heal itself. So we've set this up so that we don't get nagged as often. And then Crontab itself has a totally awesome supportable unit test framework for all the jobs. And we don't really aim for 100% coverage. We're just really trying to test for valid input and output. Because we've set this up, this is something that contributors to Socorro, because we do actually have open source contributors to this business intelligence system, which is awesome. They're much more able to kind of plug in and work on contributing than they could before. And like I said, we have this dependency tracking. It's, I wouldn't say completely self-documenting, but it is very well documented, and it's allowed us to create stuff like this. It's not easy to see, but it's a visualization that another team member, I think it was Juanan actually, that made this. And in green you can see what's run recently and succeeded, and then in red you can see the jobs that have failed and anything that might be dependent on them. So occasionally we'll have reports clean failing, and then of course everything, is kind of sad. But it's really nice to be able to, at a glance, see what's going on here. And it helps people from other teams also see what our cron jobs are and how they're doing. And this is available actually if you just go to the interface for crash chats. So not everything is wonderful in Crontab Paradise. So here's a quick review of some of the ongoing issues we're still kind of working on. So like I mentioned earlier, the configuration management is very complex. We made the classes and the class management really simple, and the complexity had to go somewhere. So like I said, most environments don't need that much flexibility. So I think in the future, currently we ship a couple of configs that were very easy to use, and in the future, there'll probably be even a more stripped down configuration for it. Our system stems from having 4 or 5 of these data storage systems and a lot of complexity in there and extremely modular components, which not everybody needs. Another thing that sort of is a special problem for us is that our one-off runs aren't very simple. So if something fails in a completely catastrophic, unexpected way, or in a way that makes it look like it succeeded, because of the way that our stored procedures work, we just have problems with this. So this is some future work for us. We need to kind of document the way that our stored procedures work a little better and implement some better fixtures, test data that fails in the ways that we regularly see. And unfortunately, we don't have a great story for parallel execution. Crontab will just take the list of jobs that you give it and run them in dependency order and alphabetically. Of course, Peter who wrote this was like, well, you could always split up the jobs manually. Yeah. We've all been there, we've all done it. But it is an area of work that a couple other people on the team are interested in making it parallelizable and making it a standalone daemon so that you don't have to launch it from cron. It's not a terribly large amount of work, and it's something that we're interested in fixing. And if there are people here that actually want those features, that would be motivating to us. So we've been running Crontab in production as part of Sakura since February of 2013. And the module itself, like I said, is now running in our stage environment. And it's going to get deployed in the next 1 to 2 weeks. A couple of the dependencies, just so you know, Python 2.6 or higher, and also Postgres 9.2. And the reason for Postgres 9.2 is because we are using the JSON data type to store exceptions. It's something I actually got another team member from that, how does the Firefox get made diagram. One of my buddies on that team was wondering if we could use it with MySQL. Unfortunately, it would be difficult right at this exact moment, but it is something that we could probably refactor to make easier. So here's how you get in touch with us. Peter's giving a talk in San Francisco on June 10th. It's probably going to dive more into the internals of it, talk about a bunch of other use cases, and it's going to broadcast live on airmozilla.com. You can also ping us in the Breakhead channel on irc.mozilla.org, and the Crontab repo is there, and you can file issues there. And that's what I came to talk about today. Any questions? Yes?
I don't have a question, I just thought that was awesome.
You didn't think I could consume, was that like those 20 solid minutes of cron? Anybody else? It's just so simple, you're all just going to run out and pip install right now, right? Oh, over there? Yes?
Do you do anything to detect and resolve cycles in your dependency graph?
No, I don't think so. Our use case has been so simple so far. I should ask Peter. I don't know for sure. It hasn't been something that's come up because, like you saw in that diagram, we've only gone 4 levels of dependencies deep. Yeah, that would be good to implement. Yes.
You said you're using the JSON data type in Postgres.
Yes.
How has the performance been for you in an actual production-like setting?
Oh, awesome, because these are tiny. This is nothing. We also use JSON in Sakura itself, and that is more, so our main read-write database is 1.5 terabytes, and I would say more than half of the database at this point is JSON. I wouldn't say that the performance is great, and particularly if you compare it to the normalized schema that we're using, there's no comparison. But it is certainly convenient, and it is way faster than Hadoop. So just to give you an indication, we took a couple of the reports that we were using, and this one took somewhere between 4 and 6 hours to complete. We shoved all the exact same data into Postgres, and it was 10 minutes. So not everybody is going to experience that amazing aha moment with their data. We're mostly looking at JSON metadata that's fairly well structured in the JSON objects themselves, but it was pretty shocking to see that kind of a performance difference, looking at one database system versus a 70 machine Hadoop cluster. Yes?
Is this wrapping existing shell scripts with Python to get an into Crontab, or are you rewriting them from scratch? Or?
We rewrote them.
Okay.
Yeah, some of the things that we were using before were already partially Python, and then had some interesting stuff around them, yeah, in some really sweet Bash. Yeah. Hey, Bash is cool, but you know. Yeah, so we rewrote the wrapper crufty stuff, and yeah, and it's all pure Python now. Yes, back there.
Did you ever use PG Agent to do your jobs instead of cron?
No, we didn't really look into that. Yes.
Can it do like multi or like cross node dependencies?
I don't know what you
Can a
mean.
cron tab entry or a cron tabber entry depend on a cron tabber entry on a different machine?
Oh, interesting. No. No.
Is there a reason why you didn't look into something like Marathon or Chronos that does like distributed cron?
We didn't need a distributed tool,
Okay.
so this is not a distributed tool. But I don't know. I don't know if the team looked into something like Chronos. For us, the very specific thing that motivated the original tool to be written were these stored procedures that were causing a lot of pain, and we wanted to be able to retry them in a safe fashion. So, and they wanted to be able to, you know, going back to the PG agent question, we wanted to be able to retry them inside the context of Socorro itself. Because Socorro is really, you know, it collects and digests these crashes, and then its primary function after that is reporting. So it seemed core to the application, and so they just wrote the tool inside it. Yes, that guy?
Timeouts and stuck jobs.
Sorry, can you say that again?
Timeouts and stuck jobs.
Timeouts and stuck jobs? Oh yeah, sorry, I haven't been repeating questions. I'm the worst streaming host ever. Timeouts and stuck jobs. We don't really, there is one job, the FTP scraper could potentially take a very long time to time out. And so for that particular one, we built timeouts into the FTP scraper itself. And so when it times out, depending on the kind of timeout that happens, that could be fine, or that could be a terrible failure, and we need to like take care of it. So I guess the answer to how we deal with that is that we build the logic into the individual jobs at this point. For stored procedures, there's timeouts built into the database functions typically, and otherwise it hasn't really been that big of an issue, so we don't have it built in. Yes?
How do you determine what's in flight? So like if you have a bunch of jobs running, do you have a way to visualize that?
We don't have a way to visualize it currently, but the logs are very verbose. And that can be dialed back too. We enjoy verbose logging, I guess. Like I say, our log files are very verbose, so you can see just by tailing the Crontab log exactly what's being run and when. And then the jobs themselves tend to be also quite verbose. Maybe one more question, or are we done? Done? Cut off? We're done? We're done.